Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's have a look at question 9, 2015. So a trig question. Joan is playing golf. She is 150 meters from the center of a circular green of diameter 30 meters. The diagram shows the range of directions in which Joan can hit the ball so that it could land on the green. Find alpha, the measure of the angle of this range of directions. Give your answer in degrees correct to 1 decimal point. Okay, so it looks like she's here, she's hitting the ball, and it can land on the green. Okay, right, so I see a dimension of 150 to this point here, okay, and alpha is the angle between these two posts here. Now my only fear is that this across here is not a straight line. Okay, so makes me think that the safer option is in fact to break this up into two triangles as such. Okay, there's a theorem on your course that says radius to a tangent, radius is perpendicular to a tangent. So that what that actually means is that for any circle you draw, you can always draw a tangent. Let me just draw a random tangent to that circle. Let me try and make it touch the circle. Okay, so we'll say this is the center of my circle. No matter where I draw that tangent, I can always draw a radius out to it that will actually be 90 degrees. Okay, it will be perpendicular to it. So if I draw another tangent at a completely different angle down the bottom, see how good my art skills is now, that's not a tangent. Okay, I can come at it from a completely different direction and again form a 90-degree angle. So that theorem on your course states that radius to a tangent is 90 degrees. Okay, so what do I mean by that? Well, I can then bring out another radius out here to this dimension that's 150 and form a right angled triangle. Okay, so it's an isosceles triangle in that case, so the line down through it is going to half that angle. So by dropping this perpendicular right down here, it is exactly cutting that in two. So when I solve it for one of the triangles, I'll just need to multiply the answer I get by 2 to get that full alpha angle. Okay, so let me try and draw one of those triangles. So straight down and then a 90 degrees coming at it. Okay, so 150 diameter is equal to 30, therefore your radius is 15. So that's why that one up there is 15. And I want to find this angle down here, and let me call it, well, X is a bit close to alpha. Let me call it Y. Okay, so again, using right angled trig. This is my hypotenuse, this is my opposite, so this must be my adjacent. Okay, opposite. Silly old Harry caught a herring trawling off America. It's important you put this stuff down, okay? Because what it is signaling to whoever's correcting your paper is that you actually understand it's a right angle trig question and that you understand right angle. So just in case you mess up from that point in, they now have established that you actually know what the question is all about and you will get some of the partial marks for it, okay? So it might feel a little bit silly putting it down, but absolutely not at all. Okay, so which one is it? I am looking at opposite and adjacent. So that looks like a tan for me. Yeah. So get the tan inverse. And I am getting 5.71 degrees for that, okay? So that's that angle y. So therefore, alpha is equal to 2 times y, so it's equal to 2 times 5.71 degrees. So it's actually equal to 11.42 degrees is what I got for that one.
Eva, would it not be the hypotenuse in that case? That's 150. Because that's the vertical distance there, or the.
Oh, did I read it wrong? I did, didn't I? Yeah, thank you. She's 150 meters from the center. So from the center. Yeah, thank you. Yeah, you're right. So just to correct that, it's the one in the middle that's 150 meters, and that's what I get for reading it fast, okay? I just took it as this distance here. Thank you. So let me fix that. So you swap him over. He's 150, which is the hypotenuse, and so he must be the adjacent. So now I'm looking at opposite and hypotenuse, which is sine. Okay, so how does that change things? Let's fix her up. Let me rub it all out because it's probably just as handy. So opposite over hypotenuse, which is equal to 15 over 150 again. So you can see that the maths are the exact same. It's just the identity that has changed. So it's the sine inverse of 15 over 150, which is equal to 5.739 degrees. Alpha is still equal to 2y, which is equal to 5.739 degrees. So multiply him by 2, 11.48 degrees is what I'm getting there to 2 decimal place. To 1 decimal place, 11.5 degrees. Okay, so thank you. Good catch. Right, so that was part A. Part B. At the next hole, Joan at T attempts to hit a ball in the direction of the hole H. Her shot is off target and the ball lands at A, which is a distance of 190 meters from T, where the angle ATH is 18 degrees. TH is equal to 385. Find the length of AH, the distance from the ball to the hole, correct to the nearest degrees. Okay, so again, just like we've been doing in all of the other questions, we can treat this as a non-right angled triangle, which is how I'm going to do it in a minute. Or of course, I could drop a perpendicular down here and break this dimension that I need. Basically work it out using right angled trig. Now you don't have enough information yet over here to be able to solve it. So you either have to find an angle or you have to find the lengths of the sides and use Pythagoras Theorem. Okay, and I'm going to hazard a guess that you're going to end up finding the 2 lengths of the sides using Pythagoras Theorem. Okay, perfectly fine to do with right angled trig if that's what you prefer. The other option is to see it as a non-right angled triangle as it is given here and just to use the sine rule or the cosine rule. Okay, and like we've been saying, it doesn't matter which one you use. I need to find AH, which is that side over there. What you'll find from practice is that the cosine rule lends itself when you have loads of information about sides, whereas the sine rule is better for when you have an even number of sides and angles, okay? So I have one side angle pair for the sine rule. The problem is I don't have another side angle pair, okay? So I can't actually use the sine rule. So it's the cosine rule. And again, what we've been saying, let me write it down first so you can see it. the angle A is across from the side A, okay? So if this is going to be, and it has to be your only angle in the question, this side that's across from it has to be the side that you put here, okay? Very, very similar to Pythagoras' theorem and C having to be the hypotenuse. Okay, so x squared is equal to 190 squared plus 385 squared minus 2 times 190 times 385 times cos of 18 degrees. Okay, and everything on the right is just a number, so you can put it in all in one fell swoop. So 190 squared plus 385 squared minus 2 times 190 times 385 cos of that 18 degrees. And I got 45,185.43, and then get the square root and hit the answer button on your calculator, and you're going to get 212.5687 for that, or what do they want to the nearest meter? That would be 213 meters. Okay, so I think actually in that case easier with non-right angled trig, so the cosine rule. Okay, the next one. So at another hole where the ground is not level, Joan hits the ball from K as shown. The ball lands at B. The height of the ball in meters above the horizontal line OB is given by this equation here, where T is the time in seconds after the ball is struck and H is the height of the ball. Find the height of K above OB. Okay, so let's go back and have a look at this. H is the height of the ball. Okay, and T is time in seconds. Okay, so there are my two variables. I have to find the height of K, so I'm solving for H. So H is equal to minus 6t squared plus 22t plus 8. Okay, so I'm solving for H, which means I'm typically subbing in for T. Okay, if you're going to find the height of K above OB, then no time has passed at this stage. So Joan is still standing on that spot. No time has passed. So in this case, T is equal to 0. Okay, so H is equal to minus 6, 0 squared, plus 22 times 0, plus 8. So that height is equal to 8 meters. Okay, I was just looking for the units. So 8 meters. Okay, next part. The horizontal speed of the ball over the straight distance is a constant 38 meters per second. Okay, when I see a question like this, and it says find the angle of elevation from K from B correct to the nearest degree. So there's two things I want you to keep in mind when you see a question like this, okay? Because it is height or distance, okay, and we get a quadratic equation, I've always two things at the back of my head, and then when I see speed coming up here, I'm thinking one is calculus, because if you differentiate a distance equation, or height in this case, height is just distance above the ground, if you differentiate it, you get speed. Okay, so keep calculus just there in the back of your head, and you're just going, I wouldn't be surprised if I saw calculus coming into it. Now, when they actually give you a value for speed, it may not be. So the other thing you need to keep in your mind is, of course, distance, speed, and time, Dad's silly triangle. Okay, because that is the other thing that links together distance, speed, and time. And if you think we have time here, we have distance here, and now we have speed, okay? So they are the two things that are playing around in the back of your head as you're reading this question, not trying to distract you in a way, but just kind of going, okay, I could end up using these, okay? So let me take a picture of him. Let me move him across. And let's try and figure out what's happening over here. So find the angle of elevation of K from B. Okay, so B is over here. So angle of elevation, you're looking up. So that's the angle that you want there, okay? Which is, of course, part of this triangle here. Okay, if it's an angle of elevation, if it's an angle you find and it's right angled, okay, it's going to be a sine, cos, or tan. Okay, so sine, cos, tan. Okay, then I need two sides. Okay, to find an angle, I need to have the other two sides. So I have three options for sides. Do I know any of them? Well, yes, I do know the distance of K above OB. Okay, so we have just found out that that side there is 8. And I need another side. Okay, so let's go back. Okay, so I have a function or a quadratic, whatever you want to call it, okay, here. Okay, which describes the trajectory that we're going through here. Okay, that function that they give me describes that. And you know that if you solve a quadratic, you get the 2 points where it crosses the x-axis, okay, or crosses ground in with respect to this question. So if I solve that, if I solve that quadratic, I am going to get these 2 points here, which are the times that the height is 0. Okay, so let me take down that h equation again. So h is equal to minus 6t squared plus 22t plus 8. Okay, now if I let that equal to 0, in other words, I'm saying when is the height 0, I'm going to find this point and this point here. Okay, and it's obviously this one I'm interested in. I'm not interested in one that occurs before time, and then this is our reference point. Okay, so let's solve this one. A is equal to minus 6, B is equal to 22, C is equal to 8. So T in this case, or you can call it X, is equal to minus B plus or minus the square root of B squared minus 4AC all over 2A. So it's equal to minus 22 plus or minus 22 squared minus 4AC all over 2 times minus 6. Okay, I'm putting the square root bit into the calculator. 22 squared minus 4 times minus 6 times 8. So I've got minus 22 plus or minus 26 all over minus 12. Okay, so let's split that one up. Hit the fraction button. I have minus 22 plus 26 all over minus 12. So that's going to give me my my negative one. And let me go back and hit minus on that. And I'm going to get 4 for the other one. Okay, so at B, time is equal to 4. And I presume it's 4 seconds. Yeah, so 4 seconds. Okay, so I hope that makes sense. I solved the quadratic. Okay, I asked myself, when was the height equal to 0? That's a height equation. So when is it equal to 0? And I got minus 1/3 here, and I got 4 here. Okay, so therefore, can I get the distance here? Well, yes, I can. I use Dad's silly triangle. Okay, so distance is equal to speed by time. So it's equal to that 4 seconds that I just found by the 38 meters per second. So 4 by 38 is 152, okay? So the length of him is 152 meters. Okay, so like I said, keep calculus at the back of your mind, keep Dad's silly triangle at the back of your mind. So find the angle of elevation then. So we label our sides. 8 is my opposite, he is my adjacent, and he is my hypotenuse. Okay, so it is actually tan this time. So the tan of the angle equals opposite over adjacent. So therefore x, the angle, is equal to the tan inverse of 8 over 152. Get my calculator. Tan inverse of 8 over 152. And I'm getting 3.01 degrees for that. And to the nearest degree, 3 degrees. Okay. At a later hole, Joan's first shot lands at the point G on the ground that is sloping downwards as shown. A vertical tree CE, there's my tree, 25 meters high, stands between G and the hole. The distance GC, there's GC, is 25. The angle of elevation at G to the top of the tree is theta, where theta is the tan inverse of a half. The height of the top of the tree above the horizontal GD is d meters, is h meters, and GD is equal to d meters. Write D and CD in terms of h. Okay. Sorry, I was looking at the diagram as I was reading it. Okay, so I'm at G. I see two triangles. We have theta, we have D, and we have h. I see another right-angled triangle down here. We have D. We have a distance here. Do you see it would be 25 minus h would be the distance here. I don't know what this angle is. This side looks smaller than this one, so I'm thinking they're not the same. Okay, and then of course I have a non-right-angled triangle here with a distance of 25 here, distance of 25 here, and that's all I have. Okay, write D and CD, so tan inverse of a half. Okay, do I know anything else? Everything else is in the diagram. Write D and CD in terms of H. Okay, so I'm going to draw that right-angled triangle first because it has D in it. There's H, and there's my angle. Okay, so I can say then that tan of that angle, probably should label my sides, that's opposite, that's hypotenuse, that's adjacent. So tan of that angle is equal to opposite over adjacent, so H over D. Okay, I'm looking up here and I'm trying to link these two together. Okay, so can't I write this one step further and just get the tan of both sides? So tan theta then would be equal to a half. So what did I do there? Well, I got the tan of both sides, and tan inverse and tan cancel. So it's kind of like the opposite of what we would do. So basically tan theta is also equal to a half. So couldn't I say then that H over D is equal to a half? Okay, so I have to write D in terms of H. So D is on the bottom. So can I flip both sides if that's okay with you? So D over H is equal to 2 over 1. Or D is equal to bring up the H, 2H. Or 2H over 1, but 2H. Okay, so I hope that one makes sense. Write CD in terms of H. Well, the length of CD in terms of H is 25 minus H. Is there any more I can do with him? There's not really. I don't have the angle, any of the angles in this triangle, so there's no point doing it in terms of a triangle. Could I use Pythagoras Theorem? No. Yeah, so that's about as good as I can get with that one. So D is equal to 2H, and the length of CD is equal to 25 minus H. Hence, or otherwise, find H. Okay, so let's have a look at this fella. Okay, find H. Okay, so again, I can either use this triangle here, or I can use this triangle here. Okay, I don't actually know any of the angles. I could find one out, I suppose, using that one. But I could also use Pythagoras Theorem, which is what I'm thinking. Because I have D here, I have this side and I have this side. Let me try Pythagoras Theorem on that bottom triangle because it seems to be the one that I have the most information about. So let's try that and let's see where does it bring us. So I'm drawing that bottom triangle here now. He's 25. He's D, which we know is 2H. And he's 25 minus H. Okay, so find H. So 25 squared is equal to 25 minus H squared plus, I'm going to write it in terms of H, 2H ought to be squared. Okay, let's see, do we get a quadratic for this now? Very handy. So 25 squared is 625 equals to, okay, that's 25 minus H by 25 minus H, don't make that mistake, plus 4H squared. So 625 is equal to 625 minus 25H minus 25H minus H squared plus 4H squared. Okay, let's bring everything to one side. So they will cancel. So I'll end up with 3H squared minus 50H being equal to 0. My apologies. He should be a 5 because minus by minus is a plus. Okay, let us factor out a H. Let us indeed factor out a 5H. So 5H is equal to 0, or H minus 10 is equal to 0. H is equal to 10, or H is equal to 0. Okay, so H is equal to 10 meters is what I make out for that one.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.